Have you ever looked at a massive role-playing video game and thought, I want to build a version of this myself, a way to create your own world from scratch? It is an incredible creative ambition. Some of the most popular games are built by a few friends in a single month. Other projects involve hundreds of developers and millions of dollars, yet they end up trapped in development for years before being abandoned. The difference usually comes down to a trap that is very easy to fall into. When you have a great idea, the urge to open your computer and immediately start typing code is intense. But without a roadmap, the money runs out, strange bugs start appearing, and the code becomes a tangled web that is impossible to manage. To avoid that mess, we use software engineering. Instead of just writing code, you treat the project like you are constructing a physical skyscraper. You need a solid blueprint before you pour the concrete. Surviving a major build depends on answering 3 questions before you write a single line of code. How much will it cost? What could go wrong? And how do we organize all the moving pieces? Let's start with that first question, figuring out exactly how much time and how many people your game will require. Kokomo predicts workload based on game size and complexity. The K-lock variable represents code size in thousands of lines. For 50,000 lines, we input 50. We apply project multipliers accounting for team size. The formula calculates 100 person-months of effort. However, this basic calculation assumes you are working under perfect conditions. In the real world, projects are rarely that predictable. To get a realistic number, engineers use cost drivers. These are real-world adjustments. If you are working with a team of beginners or using slow, outdated tools, the formula increases the estimate to account for those delays. Using math to estimate costs prevents studios from running out of money by turning guesswork into a predictable budget. Next, we have to predict what will go wrong, because something always does. A lead artist might quit, the requirements might change, or your servers might crash on launch day. Anticipating these problems is a continuous process called risk management. We identify and prepare for these threats long before we start the build. To figure out which threats matter, we use a probability versus impact matrix, prioritizing project killers over minor distractions. Think about a catastrophic server crash. The chance is moderate, but the reputation damage is massive. That risk plots directly into the top right corner, the high priority zone. For those high priority risks, we build specific backup plans, like purchasing secondary cloud servers. We call this risk mitigation. We aren't eliminating the risk, but we are reducing the damage it can do. Active risk management ensures you aren't just reacting to disasters as they happen. You are following a roadmap that already has a plan for them. Finally, we have to organize the game's architecture so that upgrading one feature doesn't accidentally shatter the entire system. We use modular design to divide the game into independent chunks. Inside each chunk, we look for cohesion, measuring focus. A player module handles actions like running without being cluttered by unrelated tasks like processing credit cards. We also measure coupling, how much chunks depend on each other. If the player module directly changes the enemy module's internals, they become dangerously tangled. Instead, the player module simply sends a message asking, "Did my hit land?" and the enemy module securely answers. When modules are highly focused and independent, the software remains flexible and easy to upgrade